So first of all, I would like to thank you, the OpenResty organizations, for giving me the chance to be here today. It's my first time in China, and I'm looking forward to coming here again. Before we start, I'd like to give a quick intro on who I am and what Mashape and the company behind Kong does. I'm Marco Palladino. I'm the co-founder and CTO of Mashape. I'm one of the core committers of Kong as well, and I'm originally Italian. So I moved from Milano with my other co-founder, Augusto, to San Francisco in 2010 to start the company. The company is Mashape, and our HQ, it's in San Francisco and Toronto. The company has been founded in 2010, so we've got 6 years of experience with the API requests, consumers, deployments, as well as enterprise deployments. The company started as an API marketplace. The API marketplace was a product on the cloud that allowed you to publish and consume APIs. So if you are a developer and you had an API, you could go online, publish your API, and then other developers could consume those APIs. In 2015, we decided to open source the core technology that was powering the marketplace. And that technology is Kong. In short, Kong is an open source API gateway for APIs and microservices. It's something that you put in front of your APIs, and then Kong handles additional features and middleware on top of those APIs. Kong itself, it's built on top of OpenResty, and it's available from the website and from GitHub. A quick intro about what Kong does and why Kong got so popular in the past year. Kong was open source in 2015. As I said, was the core technology of the API marketplace, and we decided to make it available standalone as an open source project. Since then, a year and a half, Kong has more than 1 million downloads and a large community of developers all around the world. On GitHub, it's the most popular open source API gateway. Around the world, developers are starting meetups spontaneously without even our help to talk about Kong and show how Kong can help their deployments. The reason why Kong got so popular, it's for two main reasons. One, it's because of Kong itself and OpenResty and the way it's built. And the other reason is the shift that we've been witnessing in software architectures, transitioning from monolithic code bases to microservice-oriented code bases. So this new way of building software, it's in a way leading the adoption of Kong into these new deployments. So first of all, Kong, it's open source and built on top of OpenResty. So OpenResty has proven to be the perfect technology fit for Kong. It's fast and performant, and that allows us to script Kong with Lua plugins. And plugins are the secret sauce of Kong. Plugins are middleware functions, middleware features you can add on top of your request and response lifecycle. A plugin can be authentication plugins, like, for example, key authentication, basic authentication, OAuth, or security, or rate limiting. So plugins are Lua middleware that hook into the OpenResty events, access by Lua, request body by Lua, header filter by Lua, and extend the way requests and responses are being provided to the final client. Kong provides a nice internal API so that you can easily build your own extensions, your own plugins on top of OpenResty and Kong. It's platform agnostic, so Kong itself ships with OpenResty bundled. So when you install Kong, you already, the deployment, the distribution already installs the underlying OpenResty on the system. It runs anywhere. It runs in the cloud, bare metal, on Docker containers, Kubernetes, Mesosphere, on any platform. Kong provides a RESTful API for managing plugins, consumers, APIs, and the entire system. So the RESTful API, it's available on an administration port, and you can integrate and consume the administration API in your DevOps workflows, in your scripts, in your applications, to command Kong and tell Kong how to work. Think of it, think of it as an OpenResty administration API that's built on top of OpenResty, and it allows you, through RESTful requests, to control OpenResty. It's, can get up and running very quickly, and because at the end, it's built on top of OpenResty, therefore Nginx, it's also very performant and scalable. Kong, over the past year, has seen an increase of 27x year over year of adoption. So these are running instances, production instances that are running all over the world in enterprise deployments or developer deployments. This is the open source Kong, and each one of these Kong instances has an OpenResty instance running. We know this data because there is a feature called anonymous reports. And anonymous reports, you can disable it, allows us to see the errors as they happen in the underlying Nginx process. So we can fix them in bug fix releases, but you can disable it. Another reason why Kong and therefore OpenResty are being adopted in API gateway deployments, it's because there's been a shift in how software is being built in the past years. Software used traditionally to be a monolithic code base, a huge block of code that implemented all the features, or most of them, and APIs used to be an afterthought, something that companies and developers used to create later, after, to connect their monolithic code base with, for example, mobile clients, or to create a public developer community and become a platform. So this is the SOA word, the SOAP word, and only in the final years we have seen RESTful deployments in this word. In this scenario, companies used to use closed source, black box API management solutions that are very hard to scale, very hard to configure. So these solutions could be, for example, Meshery, which is cloud only, or Apigee, which is on-prem, or Treescale, which is, for example, on-prem and in the cloud with cloud dependencies. In this use case, having a closed source API management solution was the right fit. And the traffic they were handling was mainly public traffic or partner traffic. But with the adoption of Docker, containers, and new cloud platforms, the way software is being built has transitioned from this way to that way. Now we have companies' architectures that are made of many, many APIs. APIs are not an afterthought anymore. APIs are something that come with a microservice since day one. It's something that's been built from scratch since day one. And when you have so much APIs and microservices inside of your infrastructure that are handling more and more internal traffic than public and partner traffic, you need to have a flexible and scalable solution that allows to manage and orchestrate all of this traffic. And so using older solutions that were a great fit in this use case, it's not a great fit in that use case anymore because you need to be able to extend, to scale, and to deploy easily that API gateway. So that's why OpenResty has proven as the right technology fit for Kong. It's built on top of Nginx, as you know, and developers are familiar with Nginx and they trust Nginx. So OpenResty, being built on top of Nginx, it's a great, strong +1 for Kong. And then Kong itself builds features on top of Nginx, on top of OpenResty, to provide easy way for developers and DevOps to protect, manage, and orchestrate their infrastructure by using Kong in a single DC or a multiple DC. Just to make an example, on the right side, we're seeing the Netflix of the world, the Amazons of the world. On this side, we're seeing legacy enterprise software. Every company wants to be, architecturally speaking, wants to be like Netflix, like Amazon. And open source technologies like Docker, containers, Kubernetes, Mesosphere, OpenResty, and Kong are leading this transaction. So I'm gonna, show you the pros and cons of a monolithic and microservice architecture before we jump into Kong and OpenResty. This is very important to understand why Kong is being adopted. So this is your typical monolithic architecture. You have, all of your services built in one code base. you put everything behind a load balancer, and when you want to scale, you just redeploy over and over again the same huge code base. Architectures have transitioned from this to this. Now we have a microservice for each different domain and for each different business logic. So before we had customers' orders and invoices all together in one code base, and now in a microservice-oriented architecture, we have these different services that are isolating the functionality and providing specific logic for each one of those entities. You can put all of them behind a load balancer, and each one of them ideally would talk with a separate DB schema. You will then have event handlers to manage the events across your cluster and manage synchronizations and consistency across all of these different entities. There are pros and cons for both approaches. So one of the pros of a monolithic application, it's the fact that it's simple to start with and it's great for small code bases. There's not much architectural complexity and everything can be built in one single place. So it's great for early development speed. When you get up and running, you start adding logic to your code base, and in the early days, that's actually a great fit. It allows you for easy testing, especially integration testing, because when you want to test the big picture, you just start one application and then run your tests. And ID support has been traditionally, built towards this kind of deployments. But of course, there are cons. It's not ideal for growing code bases. So I guess there are lots of developers here in the audience, and maybe some of you also work for enterprise companies. And so you have seen how in enterprise companies, as the code grows, the scalability around the code and around the team becomes a big mess. Slower iterations in the long term. As the code base grows, it's harder for new developers and for existing developers to get up and running at speed in improving and adding new features to the code base. Because of that, it becomes harder to innovate. Let's say that, for example, we want to adopt Cassandra or MongoDB in one of our microservices. In a monolithic code base, it's harder to isolate the use case. And if something goes bad, everything goes bad. And because of that, it's a steep code learning curve. It takes longer and longer as time goes on to learn the code base and improve the code base. Microservice-oriented applications are fixing some of these problems, but of course, they're also adding some cons. So it's very important to understand what's happening here. For larger applications, microservices are a very good fit. You can isolate individual functionality in different components. You can then effectively have better agility in the long term. Microservices is not just a software architecture pattern, it's also an organization pattern of the team and the company. You can now build small teams around each one of these microservices, and each team will be responsible for that one specific feature. Because they're small, they're easier to learn. If I'm hiring a new developer in the organization to work on a microservice, the code base that they're exposed to, it's much smaller than one of a monolithic application. So it's much easier to understand. And of course, you have isolation for scalability and damage control. If a microservice goes down, just that one individual component went down. It's not the entire application. You can also scale microservices independently from other components. But there are more moving parts. So if your team organization is not ready and does not have the right structure to move toward microservices, then having more moving parts could be a problem. You now have to deal with infrastructure requirements that you didn't have before with monolithic applications. You now have to monitor all of these different microservices and have a logging solution and a DevOps workflow that allows you to keep track at any given time on all of these different services. You have a problem of consistency and availability. If I'm using a service to create an invoice, to create an order, and then from that order, I need to create an invoice, now I need to make this whole transaction consistent across multiple microservices. This is something that we didn't experience before with monolithic code bases. And it's harder to test. I mean, it's easier to test if you want to test the individual component. It's harder to test the big picture. Because now to test the entire software, it's not just about running one huge application and then you run your tests. It's about running the entire infrastructure with all of its different components. And so it gets a bit harder to test this. So why an API gateway? Once we have all of these APIs and all of these microservices, the API gateway becomes the orchestrator in this infrastructure. The API gateway pattern, it's a very popular pattern that's working very well with microservices. Instead of having the client making requests to each one of those components, you have clients communicating with an API gateway. And the API gateway itself will then communicate with the upstream services. The API gateway, because it's the entry point for all the internal and public or partner consumption, can then provide new features to optimize how requests are being sent, to collapse those requests, and more. In the case of Kong, it's where Kong lives, and this is where OpenResty lives. For example, optimized endpoints. Let's say that each one of those services returns a different response. So we have, for example, different JSON responses. And with an API gateway, we can now build a virtual endpoint that effectively aggregates and collapses all of those different requests and all of those different responses in one unique response. So the client, instead of making 3 requests, the client only makes 1 request. The gateway takes care of handling all the complexity of the upstream services and then return an aggregation of the responses. And so all of those individual responses can be aggregated in one unique response. This has very good advantages because if later on we decide to update and change how the microservice works, we can do that without breaking clients. You know, when we have an API, one of the hardest things to do is to make changes and updates over time without breaking the client implementations. The gateway allows you to create an abstraction layer on top of the complexity of our infrastructure. Therefore, the API gateway allows you to have a long-running API that's less prone to breaking changes. But this is just one of the things an API gateway like Kong can do. An API gateway can also manage authentication, security, traffic control, DevOps processes, deployments, logging, transformations, you name it. For all of those APIs that either are internal or available to everybody to consume or just for partners, right? So let's say, for example, we have APIs that we want only specific partners to be able to consume. With the API gateway, we can configure the rule set so that only specific clients can consume those APIs. And there is a new trend going on, especially in North America. FaaS, function as a service, like Amazon AWS Lambda. They're called serverless functions. So you deploy not an entire service, but you deploy the individual function endpoint in a cloud environment. And so gateways can also help with that use case. You know, I'm going to go ahead and show you some examples of how an API gateway like Kong and OpenResty can improve some very specific use cases. So, for example, an API gateway and OpenResty can be a load balancer that can aid in, that can help in blue-green deployments. OpenResty has the balancer by Lua directive, which enables this transition very easily. And so we can, for example, if we have a, if we want to deploy a new version of our service, we can instruct the gateway to do blue-green deployments so that the traffic switches from the old version to the new version. But we can also handle more complicated use cases. Now, Nginx allows to do this with weights in upstream directives. What Kong and OpenResty do, it's they're providing a clustered interface available to a RESTful API to execute these operations. You don't have to redeploy OpenResty with a new configuration. You don't have to redeploy Nginx. You can just use the RESTful API of Kong to make these changes on the fly on every node. If you have 1 node or 100 nodes, the data syncs up and propagates. So that's the advantage that Kong brings to the table. And so, for example, canary releases, where only a specific percentage of the traffic goes to the new service, just in case you want to make sure the service it's not broken, and then we can get more confident to make 100% switch to the new one. So load balancing, it's a very common use case again. There are different ways of doing load balancing with an API gateway. You can have a load balancer in between the gateway and the service. You can have the API gateway itself being the load balancer. Or you can have DNS-based load balancing. So the load balancing, it's being done with a service discovery tool like etcd or Consul. Every time the gateway makes a request to one of those upstream APIs, the request is being load balanced based on the DNS resolution that Consul or etcd give you back. Because Consul and the etcd can return randomized DNS resolutions for each DNS query, effectively we are load balancing requests on the DNS level without leveraging any load balancer. And these, especially in container architectures and environments, it's a very useful use case. With containers, we don't have anymore the concept of nodes. We don't have long-running nodes. We have containers that scale continuously, that are short-living, and keep scaling and shrinking over time. So there is no more concept of node. There is the concept of container. And to understand where all of these containers are, service discovery tools like etcd and Consul can help us. Or again, circuit breakers. Let's say that we have 3 different services behind the gateway. And one of them randomly starts adding too many, responding with too many errors, too many 500 response errors. The circuit breaker, when there are too many errors, can open the circuit and no more requests will be able to go to that service. This gives us time to debug the problem without overloading the entire system. Then once the system it's running again, we can close the circuit and the request can keep running. This, it's only possible with the microservices because state and isolation, it's being handled not by the service itself, but by event handlers that are propagated in the cluster. One of the biggest problems that project managers, developers, one of the biggest mistakes they make, it's thinking that building a microservice or building an API, it's the same as running an API, Building an API, it's only 50% of the work. Building the endpoint, building the JSON response, it's 50% of what you have to do to have a successful production enterprise-grade environment running. The other 50%, it's about managing and securing the APIs, it's about monitoring them, and it's about providing a good documentation for them. So API gateways can help in all of these use cases. Kong sits in the middle of your infrastructure between all the traffic and all of the requests that are going in your application. Kong orchestrates these different requests, protects them, provides an API for automating those requests, and can easily integrate with your existing DevOps workflow. Kong, for example, can automatically send logs to Kibana, the ELK stack, or Splunk, or Galileo. Kong can manage all of those middleware transformations for you on the Kong layer, so you don't have to worry about that. All of this, it's of course open source and built on top of OpenResty. So you can extend the system with your own features, with your own middleware that runs on top of Kong. And then you can add those existing features, those additional features on top of those microservices. This is what we're trying to achieve. The more APIs we have, the more microservices we have, the more common it is to have common functionality spread out all over the place. So if you have multiple APIs, we have authentication modules spread out on, all over, caching modules, logging modules, transformation modules. Kong allows you to centralize in one place the management of all of these features. So it makes eventually easier for you to, orchestrate and manage authentication modules, security modules, rate limiting modules. Kong wants to be the central place for a company's organization to handle all of this traffic. The reason why it's the perfect fit is because it can scale from 1 to X number of nodes very easily. You don't have to worry about that. So Kong provides clustering on top of OpenResty. We're going to see this later. Kong plugins are the secret sauce. Kong plugins are what deliver the extra features on top of Kong and OpenResty. Plugins are Lua modules that are working with OpenResty that can be easily configured and installed on Kong using the Kong API. So there are, bundle plugins that provide authentication, like, key authentication, basic authentication, OAuth 2.0. There is ACL, there is course, bot detection, there is rate limiting, and you name it. And the cool thing is that you can extend the system to always address the latest and greatest enterprise requirement in your infrastructure. This is how you configure a plugin. So this is the admin interface of Kong, the admin API of Kong. And if I want to rate limit an API, let's say to allow only 10 requests per second, I just make one post request to Kong, to the admin API, and boom, now I have rate limiting on my API. So you see how easy it is to use Kong and use plugins with the RESTful API that Kong provides. You don't have to change configuration files. You don't have to change and redeploy the gateway. It's all dynamic. So you can change, update, and reapply this plugin as many times you want, on as many APIs as you want, and automatically the system will detect the new change and then will provide the rate limiting on top of that API. Very easy to use. So this is an architectural overview of how Kong it's being built. And we can see on the lower end, we have Nginx, which is the core dependency of OpenResty. So Nginx handles all the low-level operations. It's a solid foundation. Developers love it. And so in a company, in an enterprise, if you have Nginx, you can get rid of your Nginx and then put Kong and OpenResty, and automatically you have all support for plugins and additional middleware. OpenResty, it's the underlying engine of Kong. It provides all the hooks for plugins to change requests and responses. And it also extends, of course, the underlying Nginx with Lua. So we can build plugins in Lua that intercept the request and response lifecycle and then can also integrate with third-party services. The community has built lots of these plugins. The Kong itself already ships with the 30 plugins bundled in, but you can build your own plugins internally and private for your architecture. On top of OpenResty and Kong, in the Nginx, Kong also adds clustering and data store support. So I mentioned before that Kong is stateless. You can add and remove servers and everything will work. But then where is the state stored? Well, you can choose. It can be either Cassandra or Postgres. Cassandra and Postgres will store all the API configuration, the plugin configuration, the consumers, the credentials that Kong is using. You can choose Cassandra. It's an eventual NoSQL, eventually consistent database. You can deploy it in a single multi-DC. It's a great fit for multi-DC deployments. Or Postgres. Postgres, it's master slave, very easy to use. And if you're more familiar with it, you might decide to adopt it. It also works with Amazon RDS, the cloud offering of Amazon for Postgres. And then on top of all of this, we have the RESTful administration API. So this allows you to control plugins, the cluster, OpenResty, using a RESTful API. So you don't have to change configuration files. It can be extended by plugins. So plugins can provide additional features that allow to extend what the RESTful API does, and can also be integrated for automation. So if you have DevOps workflows or processes, you can consume the API. To automate Kong and OpenResty. This is the underlying Nginx configuration. So we have got the nginx.conf file, which just includes the Nginx configuration file. And that's that handles the OpenResty directives on Kong. So we have the usual access by Lua, header filter, body filter, log by Lua, and so on and so forth. And those are the events that then plugins can hook into with Kong. Kong has a few main entry points. There is the proxy entry points for consuming the upstream service. So this is the client that's consuming, the consumer that's consuming the APIs. And then we have the admin API, which allows you to configure the system and configure Kong. There are a few core entities. We have APIs, we have consumers, and we have plugins. Plugins themselves then can extend the DAO, the underlying DAO of Kong, to support new entities and new features. Kong, it's not just OpenResty. Kong, it's made of OpenResty in the core, but it's also made of DNS mask for DNS resolution and Surf for clustering support. So Surf, it's the underlying Surf, it's the underlying clustering component that allows two different Kong nodes to communicate with each other. Kong comes bundled with all of these features, so you don't have to configure them by yourself. You just install Kong, and boom, you have all of this. Kong does not, so we said Kong stores in the data store all the APIs, plugins, and consumers data, but it does not request the database data on every request. It requests them once, it then caches them in a local memory using the shared dictionary of OpenResty, and then it makes them available for every subsequent request. If the data changes in the data store, then an invalidation event is being sent cluster-wide to invalidate that one specific entity that Kong has updated. And of course, it natively supports multi-DC. So each Kong node talks with each other and talks with a database like Cassandra. Cassandra itself, it's being delegated to replicate the data across multiple data centers. And Kong will just communicate with the local Cassandra installation, Cassandra cluster, to access the data. It provides a horizontal scalability. You can just add and remove nodes to Kong and Cassandra if you want to support additional load. You can choose between Cassandra and Postgres. And the clients consuming Kong can be external or can be internal. So Kong can be an entry point for your internal APIs as well. The next 0.10 version of Kong will include some very interesting features. It's one of the biggest releases of Kong and includes native Lambda support for invoking AWS Lambda functions through Kong. So now Kong can be used not just for proxying requests to a service, but can also be used to invoke a Lambda function on AWS. On top of that, then you can apply all the existing plugins that Kong provides, like authentication, rate limiting, and logging on top of Lambda. We're going to provide an easier API to do dynamic load balancing. It's called /upstreams. /upstreams allows you to add and remove target hosts so that you can dynamically load balance requests and you can dynamically configure the targets using the API. This is very significant because you don't have to reload OpenResty and Kong to make those changes, to make those changes go into effect. You don't have to redeploy Kong or OpenResty, so it's dynamic. Better SRV DNS support for DNS resolutions. That's for making a better integration with Consul, with etcd, with Apache Zookeeper. And Cassandra 3.0 support. We are also going to provide an easier way to create backups and import backups across multiple Kong clusters and Kong environments. For example, from staging to production, regardless of what database you're using. So you can create a backup with Kong plus Cassandra, and then you can import that backup in a Kong plus Postgres cluster. In 2017, we will include a few features like a configurable web application firewall that runs on top of OpenResty, a better admin API ACL, and auditing logs. So if you work for a large organization and you have many teams and many developers configuring the system, configuring the APIs, configuring the plugins, you want to be able to have traceability of who does what. And so auditing logs will allow your enterprise, your company, to understand who was the user that, for example, deleted the authentication plugin and unprotected the API. OpenID Connect to integrate the authentication with an existing OpenID provider like OneLogin or Auth0. SOAP to REST, so we can enable companies that are stuck in a monolithic SOAP code bases to move towards REST and microservices. So the SOAP to REST will automatically convert SOAP traffic to REST traffic. And then, of course, a Kong GUI. So all of this today happens through the Kong API. So you have either to make an API request or use a curl or use HTTP Postman to make requests to Kong. We want to provide a GUI that sits on top of the API so that you can easily apply those changes from a browser. So this is a requirement for some teams. Kong, it's open source. It's the foundation of the company and always will be open source. You know, just if you're an enterprise and you need additional features, you know, the company itself also provides additional software for documentation, analytics, and support around Kong. So Kong Enterprise, it's support for enterprise production deployments of Kong and OpenResty, so if you need that. We have some very interesting use cases of Kong in existing enterprises. So first of all, Kong is being used globally by lots of developers and lots of companies. These are customers that we know what they're doing with Kong. And for example, Rakuten, it's one of the biggest Japanese e-commerce websites. They're using Kong to manage 400 APIs inside of their infrastructure with all the companies they've acquired over the years. Ferrari, it's IoT. So if you buy a Ferrari car, the data, the analytics data of the car, it's being sent to Ferrari, and Kong, it's receiving this data and protecting the communication. So that's of course Kong and OpenResty. The US government with healthcare. So when the government has to share data, sensitive healthcare data between healthcare.gov and let's say TurboTax or taxing report systems, all of that communication is being protected with Kong. And and then we have other ones. So we have New York Times for publishing, Eurostar. Every time you buy a ticket from a train ticket from London to Paris, that request goes through Kong and OpenResty. So every time you buy a ticket to go to Paris from London, it's OpenResty and Kong processing that request. And then many more in other industries. This has only been possible thanks to OpenResty. So without OpenResty, the adoption of Kong, the help we are giving to these companies, and all of the developers and the community that's using Kong would not have been able to get up and running at speed with an API gateway solution. So thanks to OpenResty and thanks to the community of OpenResty, Kong has become one of the most popular open source API gateway. So on my behalf and on behalf of my team and Mashape, a great thanks to the OpenResty team, the OpenResty community, the committers, the contributors that made this possible. Thank you.
Hi, this is Gordon. So several questions. One is I never used this all sorts of like API gateways before, so it looks pretty interesting to me. Maybe my company should I should persuade my boss to use that way. But then the question comes that I heard a term like AWS has its own API gateway, right? So and you are trying to support even AWS Lambda. So with the latest AWS re:Invent conference, they bet a lot on Lambda. They even have Lambda on CloudFront. So how should I, if I'm interested in adopting Kong, what would be the most reason I can give to my boss? Say we should do this instead of CloudFront. Instead of AWS.
For 3 reasons.
Okay. Okay. Let me raise my second question then. The second question is the enterprise version you mentioned before for Kong. I see something like API analytics, things like that. So does that mean only available on enterprise version, or is there any open source plugins alternatives available as well? Okay, just these two questions. Thanks a lot.
Thank you for the question. So regarding AWS Lambda, there are three main reasons why you as a company want to adopt Kong with Lambda instead of using AWS API Gateway. The first reason is Lambda, it's a very closed system. So if you wanted to extend Lambda, you can't really. The feature set of Lambda is very limited today. With Kong, you can write your own OpenResty middleware, Lua middleware, to extend the API gateway and extend what your function does. So this is something that currently it's not possible with the AWS API gateway. And if you're an enterprise, you want to be able to build a system that can accommodate future enterprise request needs. So AWS Lambda, as of today, does not allow you to do that. The second reason is AWS API gateway, it's very slow, like painfully slow. The latency can go up to 100 milliseconds. I heard somebody had 200 milliseconds. That sometimes it's not acceptable. With Kong and OpenResty, your latency is very, very low. And even in high load environments, you'll never have a latency higher than 10 milliseconds on the process. The third reason is pricing. AWS API Gateway charges for each request. With Kong and OpenResty, you only pay for DC2 compute instance you're willing to pay for, right? So you can put everything on a small instance and handle billions of requests to Lambda using Kong without paying AWS API Gateway per request. So these are the three main compelling reasons. And as a matter of fact, on Monday, I'll also be going in Hong Kong to talk with a customer, a Chinese customer, who's transitioning from AWS API Gateway to Kong because they're not happy with it anymore. So just, with the new AWS plugin, you will be able to experiment with Kong and Lambda. So give it a try. It's already in the next branch, so you can check out the branch and play with it. But otherwise, you can just wait for 0.10, which we expect to release this month, and we'll give you out-of-the-box Lambda support. The second question was?
Yeah, it's about the open source alternatives for plugins. Yeah.
So plugins are open source. You can build your own open source plugins. You can extend the system with your own plugins. The community also has built lots of plugins. The enterprise features that Mashape as a company provides, analytics, portal, are closed source features that we only deliver as part of the enterprise package, because those are the ones we can provide support and SLA to, right? So we can guarantee a support for those. But nothing prevents you from using creating your own plugins to extend the system your own way. These are out-of-the-box products that we as a company provide in an end-to-end enterprise package that your company can choose. As a matter of fact, all of these enterprises here are customers of this entire packaging. So they're using Kong to manage APIs, and they're using the portal to create a customizable interactive experience, and they're using API analytics to extract business intelligence data from the API traffic that's going to Kong.